Hello team, this challenge is GCD, the greatest common divisor, where we're given two numbers like 4 and 6, and we need to figure out which is the biggest number that you can divide both by. In the case of 4 and 6, it is 2. 2, 4, 1, 2, 3, 6. 2 is the greatest common divisor. There are a couple ways to do this, a bunch really, but the two that I want to show today are a recursive one and another one. Okay, so for the recursive one, we always need a control to get out of it because recursion is by itself a loop. So if we have no way of exiting the loop, it will just keep going, right? For us, that's going to be the y. We're going to control on the y. We're going to see if y is equal to 0. If it is, then we return x, okay? Because x is going to be our greatest common divisor. We're going to try and reduce down and figure that part out. And we do that right here at the return. So we go GCD, we're going to funnel it back in, and we pass in two new variables. In our case, y becomes x, so we put y here, and then we we create a new y, and that y is x modulo y, okay? So not z, sorry, x, brilliant, x modulo y. So every time we switch out, the y becomes x, or sorry, the x becomes y, and then we create a brand new y. And by doing that, it works. It's something called the Euclidean algorithm, which is not a word that wants to work in my mouth right now, but uh, it works quite well. And it's pretty fast. In my testing, it's around 6 million ops per second, which is just blazing fast. But we can make it even faster, and that's the second one that I want to show today. So I'm going to take this, bring it down, and change some things. I'm going to leave all this code in here for a moment, but we're going to switch to a while, okay? So before we had the if, right, and we returned early. Well, with the while, we want to check if y is not 0, okay? So same test, not just reversed, right? The same test but reversed. So if y is not 0, then we do something. And we can, with new JavaScript, we can do assignments directly to a thing. So here we have the x and the y, just like this, and we assign them from what? Well, the same thing as this, right? It's going to be the y and the x modulo y. So we put that right down here. And then the last thing is we need to return x, which is what we did right here, right? So all these pieces fall into place. The only difference is that we're using a while loop instead of recursion, right? With that, it still works. And the beauty of this, once I clean all this up, is that this one, whereas the first one was around 6 million ops per second, again on my computer, the second one is double that. It's more than 13 million ops per second, right? So 6 million ops per second, 13 million ops per second. If you need that maximum performance, this is probably the direction you want to take, right? And you could spend some time playing around in here and doing stuff to start to really hone in on that. It's those small changes aren't going to make much of a difference at that stage, but you can, right? If you wanted to do clean assignments instead of this destructured assignment, you could probably get another 10,000 ops per second, right? At least in my testing. But this is it today. Again, not every solution, just hopefully a couple decent solutions, right? And one used recursion. We did that. The other one used a while loop. They both relied on what's known as the Euclidean algorithm. I'll be sure to share a link in the notes here on that. And yeah, let me know what you think. Let me know which one you like better, right? Did you like them? Did you hate them? Did you do it a different way, right? All that stuff. Put it in my comments. Let me know. Otherwise, today this has been GCD, or Greatest Common Divisor. And I will see you in the next one.